Hi, I'm TJ O'Brien, and this is the chemistry of onshore and offshore winds. Here's a table of contents and the topics that we will be covering. All right, now let's jump straight into it. What are onshore and offshore winds? Onshore winds are the type of wind that blow from the ocean or from the sea onto the land. And on the other hand, offshore winds are the type of wind that blow from the land towards the sea. The way that these winds are formed, interact with the environment, and chemically react are vastly different. And above is an image and a couple of notes of what we're going to be covering today and what we're going to be diving in deeper to. So you can take a look at that if you want. All right, here's the chemistry of it. So what causes these different types of winds is relative to the difference in pressure presented in the atmosphere and the specific heat of the ocean and the land. Some things to keep in mind are the heat capacity equation. The specific heat capacity of water is greater than the specific heat capacity of land. And what heat capacity is, the exact definition, is the number of heat units needed to raise the temperature of a body by 1 degree. In simpler terms, it's saying the amount of energy from the sun that is needed to increase the temperature of something. And then you need to know that cold air is denser than hot air, which is basically why hot air rises and cold air descends. All right, specific heat capacity and change in temperature. So we're going to be using the equation Q equals MC delta T, the heat capacity equation, to prove that it takes more heat energy to change the temperature of the ocean than it does the land. So we're going to be setting the heat energy, or Q, equal to our mass, which is, for all intents and purposes, we're just going to make it 10 grams, even though that is not the actual mass of the ocean, but just to keep it constant. We're going to put it at 10 grams times the heat capacity of water of the ocean, 4.186 joules per gram degrees Celsius, times our change in temperature, which is going to be an increase of 10 degrees Celsius. And then when you multiply all this out for your heat energy, you get Q equals 418.6 joules. So it's saying that it takes 418.6 joules of energy from the sun in order to create a 10-degree difference in the ocean. And then on the other hand, on the land, we do the same thing, same equation, just different heat capacities, obviously. And you end up getting 100.5 joules for the heat energy. So what this proves is that it does indeed take more heat energy to create a temperature change in the ocean rather than it does the land. So the temperature of the land will change faster than the ocean will throughout the day and night. So you just need to keep this in mind because it helps explain the pressure, the density and pressure, and why hot air rises and how it affects onshore and offshore winds. So the density and pressure of the air is dependent on the temperature outside and the time of day. So given what we proved, during the day, when the sun rises, obviously the land is going to warm up quicker than the sea will. So the air above the land gets hotter, and the air molecules begin to expand, right? Thermal expansion. As the sun hits the air molecules, they start bouncing around and expanding, which so this causes the air molecules to expand, and then there is less pressure and density in the air over the land than there is in the ocean. This causes the land air to be lighter, and it causes it to rise again, which is why hot air rises. And then it allows the cooler sea air to descend and create this onshore wind, because that air is still warming up. It's still colder, therefore it's denser, more compact. Molecules are more tightly bounded, making it heavier, causing it to descend, creating that onshore wind. And then vice versa, at night, the land air gets colder because again, the change in temperature of the land is much faster than the change in temperature of the sea, which is what we proved earlier in the previous slide. And the air molecules come closer together over the land, creating more pressure and density, causing it to descend. And the sea is still cooling off from the day when it was just warming up, just at a much slower rate, which makes the air above the sea less denser, less pressure. Therefore, it's going to rise, it's going to raise up, and it allows that denser land air to sweep under and create an offshore wind. Yeah, so that is how the density and pressure works. Now, why it's important to know about onshore and offshore winds is because even though you may not notice it, they do affect your day-to-day life. For me personally, this is why I chose this subject, because I am a surfer. So if you are a surfer, you may know that offshore winds create a very nice wave and help waves build up and pitch out and create a better barrel and better wave formation. And onshore winds most of the time tend to diminish the wave or cause it to choppy in the water, which you don't want while you're surfing. You want it to be smooth and clean. So this can greatly affect where you're going to surf, where you're going to travel to surf, and where you're going to end up getting in the water. Wind turbines. So wind turbines create energy for people to use, obviously, and they're set up on the land. They're also set up in the middle of the ocean. Offshore winds hit the ones that are set up in the ocean, and onshore winds hit the ones that are on the land. And the ones that are set up in the ocean tend to create a lot more energy because the offshore winds don't have any man-made buildings or hills or structures in their way of blocking the wind and stopping the wind speed like what happens to the onshore winds. So having offshore winds tends to create a lot more energy and power for these wind turbines, these windmills that are set up so that you can have power at your homes. Aviation. So how onshore and offshore winds affect aviation? It affects the takeoff and how the pilot is going to get you to your destination, because as a plane takes off, you want to take off against the wind because it gives you more lift and helps you get off the ground and into the air. So the pilot is always going to check which way the wind is blowing, so that they can take off against the wind with, knowing whether it's an onshore wind, offshore wind, or what direction it's blowing in. Helps you get off the ground safely and safely to your destination. So that is how the onshore and offshore winds are related in our modern day. Here's my works cited. Here's a YouTube video at the bottom that I watched that explains the equation that we dove into. And thank you for watching. Thank you for a great year, Mr. LaBonte. You rock.